Okay, let's have a look at how we'll use our solubility product and our reaction quotient to predict whether we get a precipitate in a reaction. So if we recall when we did some work on reaction quotients, we can compare our reaction quotient to our equilibrium constant to predict whether a reaction will shift left or right. Now we can do exactly the same thing by examining our equilibrium constant and comparing that to a reaction quotient for our solubility product. And to do this, we've got three steps. First thing we need to do is calculate the concentration of ions that we have present for a given reaction. We then use these concentrations to calculate our reaction quotient. And then lastly, we'll compare this reaction quotient to our given solubility product constant. And one of three conditions will be met. If our reaction quotient for our solubility product is less than our solubility product constant, then we'll have an unsaturated solution and no precipitate will form. If our reaction quotient for our equation is equal to our solubility product constant, the solution will be saturated, but once again we won't form a precipitate. And our last condition, if our reaction quotient is larger than our solubility product, it means that we're going to get a saturated solution and it's saturated with excess, so we'll actually form a precipitate in that particular reaction. So let's have a look at this in action. Let's say we have a 0.1 molar solution of lead nitrate and we add that to an equal volume of sodium fluoride. But we've got a 0.03 molar solution of sodium fluoride. The question asks us, will a precipitate form? First thing we need to write down is our balanced reaction. So we have our lead nitrate, 1 mole, reacting with 2 moles of sodium fluoride to give us our lead fluoride, which is aqueous, and our sodium nitrate, which is also aqueous. Now before we go through this analysis, we need to determine if and when one of these products will form a precipitate. And to do this, we'll need a table, and we look at the Qsp values. So our sodium nitrate is often not, or it doesn't appear on a Qsp table because it has such a large value. In other words, sodium nitrate will not form precipitates readily unless there's a high enough concentration present, and it's past that saturated solution. On the other hand, our lead fluoride, if we look at the Qsp value, we find that it's 3.3 by 10 to the minus 8. So in this particular reaction, there is a possibility that our lead fluoride will form a precipitate. So our next step is to set up our equilibrium reaction for our lead fluoride dissolved in water. We find that as it dissociates, we get lead ions, and we get, from our original compound, 2 moles of fluoride ions. From our previous steps, we had to determine what our concentrations were in solution. So to do that, we need to go back to our question. Initially, we have 0.1 moles of lead ions in solution. It's a 1-to-1 ratio of lead nitrate to lead ions. So we start with 0.1 moles per litre, or 0.1 molar. Now, our final condition when we add the two solutions together comes from the fact that we add an equal volume of both solutions together. So effectively, we're halving the concentration. So our final concentration of lead ions will be 0.05 molar, or moles per litre. Similarly, our nitrate will go from 0.2 molar, because we've got 2 lots of our nitrate for every 1 mole of lead ions in solution, and our final concentration will be half of that, 0.1 molar. Our sodium fluoride starts at 0.03 molar, so our initial concentrations of both the sodium and fluoride will be 0.03 molar. When the reaction occurs, we obviously get half that concentration, so these halve to 0.015 molar for each of them. Second step from our previous board says that we need to calculate our Qsp. So we set up our equilibrium expression, 1 lot of lead ions times our concentration for fluoride ions to the power of 2, because we have a molar ratio of 2 here for the fluoride ions. And then we substitute our final concentrations that we determined from our step 1. So 0.05 molar times 0.015 molar squared, which gives us a value of 1.125 by 10 to the minus 5 for our QSP value. Our final step is to compare this value with our original KSP, and if we do that, we find that the QSP, or reaction quotient for this particular reaction, is much, much larger than our KSP. And this indicates that a precipitate will form.